Hi guys, today we're going to learn how to prove that a quadrilateral is a parallelogram. First and foremost, remember that the definition of a parallelogram is that both pairs of opposite side need to be parallel, okay, to be a parallelogram. Otherwise, you don't have a parallelogram. In addition to that, you can show that a quadrilateral is a parallelogram if you can show that one of the following theorems is true. So, the first theorem that we have over here is that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Second theorem, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. The third theorem that you have is that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. The fourth theorem that we have here is that if one pair of opposite sides of a quadrilateral is both congruent and parallel, okay, then the quadrilateral is a parallelogram. The last theorem that we have for this section is that if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So what we need to do here in the following three examples is we need to determine if each quadrilateral is a parallelogram, and we need to justify our answer. So the first thing that you can recognize here is that here you have that this side is congruent to this one and this one is congruent to this one. Is that enough to conclude that it's a parallelogram? Of course, that's going to be the first theorem, okay? So you know that opposite sides of this quadrilateral are congruent, okay? So you put yes, okay? Opposite sides, okay, are congruent, okay? So absolutely, this is a parallelogram. For number two, what you have is, again, we want to see if it's a parallelogram, right? So what we have here is what? Well, we want the lines to be parallel, but are they? We don't know, okay? So, what can you conclude here? You're going to tell me, yes, they are parallel. Why? Okay, so I can tell you that I know that these are parallel. And if you are thinking about that, you're right. Why they are parallel? Because you know that this angle is congruent to this one in the same way that this angle is congruent to this one, with these two being the parallel lines and this being the transversal, or this being the transversal. So these two, you can prove that they are parallel. Now, can we prove that these two are parallel? Well, you know that these two vertical angles are congruent, okay? And you know that this one is congruent to this one, obviously, right? But we don't have any information from these angles, do we? So the issue here is we don't have enough information, no. Okay, and the issue is that only, okay, one pair of angles, one pair of sides, excuse me, the angles are congruent. Only one pair of sides are parallel, okay? The other pair, I don't know, okay? This is a question mark, therefore I don't have enough information. For example number 3, okay, you do have that these two sides are congruent, which is pretty nice, okay? But do you know if this is 70, this must be 70, but do you have information that it's telling you that this is 70? Not that I know. You do know that by definition of a parallelogram, this must be 110, but do you have information to prove that this is 110? Not really, okay? So again, there's not enough information, okay? And this is going to be no, okay? So what we know is that the parallel sides, okay, are not, okay, the same as the congruent sides, okay? So that's the situation here, and that's why we cannot conclude, okay? There's not enough information again, okay? So this one, we cannot conclude that it's a parallelogram. For example, number 4 and 5, they tell you to determine whether the quadrilateral ABCD with given vertices is a parallelogram. Okay, so the first thing that we're going to do here is, for the sake of this problem, I need to make sure that I graph it correctly. So I'm just going to graph it here, AB, CD. Okay, so I'm just going to graph it here randomly. Okay, you can actually do it on the grid if you prefer. Okay, but here I'm just going to graph it like this. Okay, A, B, C, D. Okay, so what we want to do here, remember the definition of a parallelogram is that the opposite sides are parallel. Okay, therefore, I want the easiest way is to do it via the slope. Okay, so what we're going to do here is that the slope, the slope of AB, I want it to be the same as the slope of CD, right? Okay, so I'm going to compute first the slope of AB. I know that the slope of AB, what's the slope of AB? Okay, so it's going to be 9 minus 5 divided by 5 minus 2, which you know that this is going to be equal to 4 divided by 3. So my hope is that the slope of CD is the same. Okay, so what's the deal for CD? You know that it's -1 minus 3 divided by 3 minus 6, which is going to be equal to -4 divided by -3, which you know that it's the same as 4/3. So indeed, these two, okay, are parallel, so we can conclude that AB, the segment, is parallel to CD, so I'm in a good position at this point. Now, you do know that this is parallel to this. Now, we want to prove that AD is parallel to BD. For that, I need to compute the slope of what? We need to compute the slope of AD, and also we need to compute the slope of BC, okay? So for AD, what you have is going to be -1 minus 5 is going to be divided by 3 minus 2. So this is going to be equal to -6 divided by 1, which you know that it's going to be -6. Okay. On this side, we have that B and C. Okay, so you know that it's going to be 3 minus 9 divided by 6 minus 5, and this is going to be equal to -6 divided by 1, which you know that it's -6. Therefore, you can say that AD is parallel to BC. Okay, so what was this? Thus, what can we conclude here? ABCD is a parallelogram. Okay, if you want to justify why, because both pairs, opposite sides are parallel. Okay, so that's a huge thing. Okay, good. So let's do example number 5. Okay, for example number 5, I'm going to do our tradition here so you can kind of visualize it. As you can see, I'm not even needing a grid, right? I know what I want to prove, so I'm just using the numbers that they are giving me, and you don't need a grid necessarily. You can use a grid, of course, if you want, but it's not needed. So A, B, C, D. Okay, so again, pretty similar to the previous one. I want to prove that they are parallel, right? Because that's the definition of a parallelogram. Actually, the name tells you parallelo means that opposite sides are parallel. Okay, So I'm going to find the slope of AB. Okay, so the slope of AB, what's going to be that one? It's going to be the slope of AB, it's going to be negative 3 minus 6 divided by 2 plus 1, and you know that that one is going to be negative 9 divided by 3, which you know that this is going to be equal to negative 3. Now the one that you want to match is the slope of CD or DC. Okay, so you know that that one is going to be 9 minus 0 divided by 2 minus 5, right? And this is going to be 9 divided by negative 3, which you know that it's also negative 3. So you can conclude from here that AB is parallel to the segment CD. Okay, so the next step here is obviously, so you know that this is parallel to this one. Now my next step is to prove that AD is parallel to BC. Okay, so I know that the slope of AD is going to be equal to 9 minus 6 divided by 2 plus 1, and this is going to be equal to 3 divided by 3, which is going to be equal to 1. Now my hope is that the slope of BC is the same. Let's see if it's true. So you know that negative 3 minus 0 divided by 2 minus 5, that's going to be equal to negative 3 divided by negative 3, which is equal to 1. So we are very happy because yes, they are the same. Therefore AD, the segment, is parallel to the segment BC. Okay, with this being said, what do you have here? Yay, we are very happy because, okay, thus ABCD is a parallelogram because both pairs of opposite sides, okay, are parallel. And that's it. That's how you can prove it. Remember, you can also do this proof via the distance formula. Okay, what would you need to prove here is that the distance from AD is the same as the one from DC, and the distance from AB is the same as the distance from DC. Okay, if you prove that those are equal, this are equal and these are equal, then you can also conclude that that's a quadrilateral, and that's also a correct way of seeing the situation. Okay, I hope that this video is helpful. Bye.